Thank you very much. And I must say I'm really honoured to be here and being invited to speak at the symposium. It has been fantastic so far, so congratulations to the organisers. I, as Frank said, I'm a statistician epidemiologist, and I've been invited to talk and give an epidemiological perspective on comorbidity and ageing. And what I really want to do, if you'll give me the freedom to do this perhaps, is to challenge some of the mantras that I think are out there around ageing in the HIV group. So what are the facts and what do we know? Well, these are data from the UK Chic study in the UK, and we can see here that increasing proportions of people in our clinics are now over the age of, they're in their 40s, their 50s, their 60s, and even older. And this is something that, 10 or 15 years ago, we really wouldn't have believed was possible. And we've seen the same sort of figures from many other settings. You've seen these graphs before. And I found this really great paper recently from the Thailand study looking at the same sort of issues essentially there, going out here to 2025, increasing proportions of people in that older age range. Now this is also set to continue. These are really great data from Michaela Smith, and she works at Imperial College. She's a modeller, and she has been working with Peter Rice's group in the Netherlands to actually look at what is likely to happen to the epidemic as we go forward. And she's been able to show in this group that the median age of people is likely to increase from an average of around 44 years in 2010, so a little while ago now, with just under a third of people over the age of 50. But by 2030, that median age is likely to increase to 57 years, with almost 3/4 of people in the over 50 age group. And of course, I guess this was also done at a time when perhaps we didn't really appreciate the benefits that PrEP might bring to this and the changes that will also have on the population. Now remember, of course, this is really largely driven not only by changes in life expectancy that we're seeing from increased use of antiretrovirals, but also continued new infections in that older age group and new diagnoses. So it's a mixture of both things that are contributing to the ageing. And again, similar projections from the region here, showing also from Teihod Light, showing that sort of increased proportion of people in the future who are likely to be in those older age categories. Now, what does ageing bring with it? Well, I think for many of us who are now ageing and have been in this field for many years, of course, it brings the inevitable increase in comorbidities. And again, using some data from Peter's group in the Netherlands, the group looking in the Age HIV study were able to look at the comorbidity profile of people within their HIV positive cohort. So this is the group here on the right-hand side, but the pointer isn't really working. So on the right-hand side there, you have the cohort profile, comorbidity profile in people with HIV. And what you can see there is that obviously as people get older, the number of comorbidities that they experience is increasing, so that you have an average of about 1.3 comorbidities. But if you then compare that to the characteristics of an HIV-negative population, you can see quite nicely that the comorbidity profile probably most closely matches that of someone who is around 5 years older, 5 to 10 years older in the negative population. So the increasing number of comorbidities, but also some signs there that there is some evidence, perhaps, that there is an increased risk of these comorbidities. And similar data here from a Taiwanese study showing increasing proportions of people as they go into their 40s, into their 50s with comorbidities. Of course, they're also expected to increase as the population ages, and Michaela showed very nicely that the proportion of people with at least one comorbidity is expected to reach, well, getting close to 100% by 2030. But more importantly, the number of people with at least 3 comorbidities, probably up to almost a third of the group by that point. And comorbidities means co-medications, potential drug-drug interactions, issues around polypharmacy, with at the moment, or 2010, 1 in 20 people on more than 3 medications, but that number going up to almost 1 in 5 by 2030. So, of course, where am I going to with this? Well, this means that the literature, of course, is abundant with stories that are reporting that people with HIV have premature aging. or that comorbidities occur at an earlier age in people living with HIV. And I'm just showing one or two screenshots from websites really which demonstrate, I think, the concerns that not only the physicians and researchers but also the community themselves have, that all of the sort of positive benefits of antiretroviral therapy might be negated by some of these more sort of increased risk of comorbidities, which may sort of then balance things out. And of course what that means sorry, is that our search is continuing for biological mechanisms that may drive this apparent risk. So there are whole groups of people who are searching and investing in massive amounts of research monies to look at mechanisms. We hear the terms thrown around, inflammaging has been referred to quite often in the literature, altered gut microbiota, although I think it's probably fair to say that actually the gut microbiome is being blamed for virtually everything at the moment, so that's probably a little bit topical. Mitochondrial dysfunction, is this driving it? Is it immunosenescence? There's lots of potential mechanisms out there that are being studied. But where I'm coming to with this is I have some concerns that perhaps in our rush to try and establish those mechanisms, what we're doing is we're actually forgetting the very, very basic rules of epidemiology. And what rules am I thinking about particular? Well, mainly confounding, and I'm sure that everybody in the audience does know what confounding is, but I mean, in case you can't remember from your sort of medical student days, confounding is where we see an association between a potential cause and effect, but where that association isn't actually a real one, but is just reflecting some other factor that is there. So, as an example, as I'm here, whenever I fly to Thailand, I spend a lot of time on a plane, but I find I end up putting on weight, and I might blame that on the flight over here to Thailand. Whereas, of course, it's probably to do with the fact that when I'm here, I just don't stop eating all the fantastic food. So there, the flight, the eating and my diet is the confounder, and actually the flight has got nothing to do with it at the end of the day, apart from getting me here in the first place. So why confounding in HIV? Well, people living with HIV do have very different characteristics as a population to the general population. Within, certainly in Western Europe, we have very, very high rates of sexually transmitted infections. We have very high rates of viral co-infections, smoking, recreational drug use. If you then add into that also issues around socioeconomic status, poverty, all of those other factors that may differ between your group of people with HIV and the general population, you can start to see that some of those factors could act as confounders. And certainly we know that many of those factors are associated with many of the comorbidities that we study. I think this is a very nice slide which really illustrates this for cardiovascular disease, and you can see HIV here on the right, but you can see around that there's a whole range of other factors that also contribute and which also could be affected for many of those other reasons within the population of people with HIV. So, what do I want to discuss? What really is the point that I want to make? Well, I have two questions that I want to focus on today. The first is really, is it true that HIV causes premature aging? Or is it simply a result of unmeasured confounding because of the selection of inappropriate control groups? And of course, the controls we use, we typically look at the general population. But we may also use that completely inappropriate term, healthy controls here. I mean, it's used quite often. What we often refer to when people talk about that group is people working in the lab, people working in their research team as control populations. And particularly for for biomarker studies, we may also look at blood bank donors as another group of controls. So, is the fact that we're using that control group, does that in itself introduce confounding? And then the second question I want to answer is what do we actually mean by premature aging? It's a term that we actually throw out quite a lot, but I'm not sure that actually everybody really understands what the term means, or not everyone is thinking about it in the same way, and we may not have sufficient data to show that. So let me start with the first one. Is it true that HIV causes premature aging? Now, most of the studies that have shown that really have been studies that have taken a cohort of people with HIV. They have then taken the group of people in that population with a comorbidity, and then they've looked at the average age at the diagnosis of that comorbidity within the cohort study. They've then compared that generally to the general population, and of course it's usually quite easy to find the average age at diagnosis of some event in the population. And quite often what has been noted then is that the average age at diagnosis is around 10 years younger or so, and that's something we're seeing fairly consistently for many of these comorbidities. But of course, when you look at this within a cohort of people with HIV, the average age at diagnosis is really going to be determined by the underlying age distribution of your cohort. And if you have a cohort of people that is younger, on average, than the general population, then your average age at diagnosis will be younger, simply because there aren't any older people there to be included in the calculation. So just to illustrate that, I've actually made up, this is one of the beauties of being a statistician, is you can just make up your own data if you want, and no one really minds too much. But what I've done here is I've created a cohort, a sort of very cohort that is typical of a general population here. We've got a range of people from, going backwards. A range of ages here going from 20 to 80. The people in red on the right-hand side are the people with the comorbidity of interest. The people on the blue are people without the comorbidity on the left-hand side. Now, within that group of people, the average age at diagnosis is 67.5 years. Now, look at what happens when I actually now take out some of those age groups to make this cohort look more like an HIV cohort. So I've taken out quite a few of the older people because we're not yet seeing those people, and I've taken out some of the very youngest group there. By doing that, the age at diagnosis has now dropped by 10 years already to 57.5, and I've actually done nothing here about the risk of the disease. All I've done is I've changed the age distribution of that population. So this is a real potential for explaining why we're seeing those 10-year age differences between the populations and our HIV cohorts. How do we deal with it? Well, there's two approaches. We can either look at the risk of a disease occurring at a given age rather than looking at the absolute age at which it occurs, or we can somehow take our general population and make it look more similar to our population of people with HIV. And both of those methods will work. And in fact, one study that's done that very, very nicely is the VAX virtual cohort in the US. This is a paper from Kerry Althoff and her colleagues. And this cohort is very nice because not only are the HIV positive and the HIV negative people in the cohort very, very well matched for age, for gender, for mode of infection, but they're also drawn from the same underlying population. So actually they're indirectly controlling for lifestyles and behavioral factors as well. Now what Kerry showed within that cohort is when you then use appropriate methods to analyze the data and you have that very well matched cohort, actually when she looked at myocardial infarction, when she looked at non-AIDS defining cancers, so NADC, and the HIV-associated cancers, actually there was no difference in the age at onset of those events in the two groups, no significant difference. The only one where she did see a significant difference was for end-stage renal disease, but 0.46 of a year translates into about 5.5 months difference. So even when she did find a difference, it was relatively small. So that's the first piece of evidence. The second thing I want to show in response to this question is data from the comorbidity in relation to AIDS collaboration, so the COBRA collaboration. And this is a European Union-funded collaboration between two cohorts that were set up to specifically look at the impact of aging in people with HIV. So the first is the POPPY study, which is I co-lead in the UK with Alan Winston, and that we include people in that who are over the age of 50 and controls. The second is the Age HIV study. I've already shown some data from that, from the Netherlands, led by Peter and his team. People in that group who are included in the older group are over the age of 45. But most importantly, for both of these cohorts, the control groups have been recruited from very, very similar populations. So largely because they're mainly white MSM in the group, we've drawn people from people attending sexual health clinics and similar locations. Now, I'm just going to show at the moment one study from that collaboration, which is a study conducted by Sabin and NIHR Kuchstra to look at the impact of CD4 or the differences in CD4 and CD8 T cell senescence in the groups. And I'm going to take you through this gradually because it's quite an important point to look at. So the first slide I'm showing you here shows the comparison between the HIV positive people in COBRA and a group of blood bank donors. Now, whether you're looking at CD4 or CD8 T cells, and whichever marker of senescence you're looking at, you can see there that there is a very, very striking difference between those two groups, which, of course, will lead you immediately to say, well, HIV must be leading to increased senescence. But when they then looked at the HIV-negative controls in COBRA, so the blue group here, what you can see actually is there is no difference for any of these between the HIV-positive and HIV-negative COBRA groups. Both of those groups, however, have higher levels than the blood bank donors. So what's driving this? Well, we looked at the characteristics. It's a relatively small study, but you can see here that overall, age and sex are relatively well matched between the groups. The one thing that is really different, strikingly different between the two groups is the proportion of people who are CMV seropositive. And in fact, though there are differences between the two COBRA groups on the left-hand side, the blood bank donors, so there's only a prevalence there of around 22.9%. And to be honest, in a group that is of this age group from the general population, we would actually expect that to be closer to 40%. So immediately this is telling you something perhaps about the blood bank donors and their lifestyles as opposed to the COBRA participants. So what did Theis and NIHR do? They then stratified by CMV status here and actually were able to show that when you do that, you see no differences between those groups. So everything really that's being driven here is being driven really by the CMV and not the HIV. So really sort of interesting point there. So what have we actually got? We have a really nice two examples of confounding. In the first case, age was acting as the confounder with the comorbidity. And in the second case, it was CMV infection or some correlate of that. So I often show this slide. I mean, essentially what we're doing when we compare our groups here is we're comparing apples and oranges. I was thinking about this yesterday. I probably should have had something like papayas and pineapples to make it more Thai food, but I couldn't find a cartoon of those, so sorry. So we need to think about confounding. So that's the first thing. Now, what do I mean by premature aging? Let's go back to that question. It is, as I say, a term that is thrown around. Well, there are different models of premature aging, and if we start with a situation where we have a comorbidity, as people get older, the risk of that comorbidity increases. In this situation here, we throw HIV into the mix, nothing happens, nothing changes in that association. So this is an example where we have no example of premature aging. But we may have a model where once HIV or some related factor comes in, then the year-on-year increase in that risk starts to go up more rapidly than in the people without HIV. And this is a model of accelerated aging. So the slope starts to change. But we might also have a model of accentuated aging. And for accentuated aging, instead of the slope increasing, what happens is that absolute risk goes up, but then the slope stays the same. Or, of course, we might have a combination. So we may have a situation where we have accentuated and accelerated aging going on. Now, why does it matter? You're probably all saying, at the end of the day, if people are more likely to have an increased risk, what does it really matter? Well, it matters because the underlying mechanisms and the etiology might be quite different. And so knowing whether we've got accelerated or accentuated aging can help us when we think about the lab studies to try to show that. But what it also means is that the statistical approach that we need to test for these differs very much. And in fact, we have to focus not only on the absolute risk, but on that slope as well. And you'll find that many studies out there claim to show accelerated aging, but in fact they don't have the data to show that. They haven't looked at those slopes. And I think the other thing to note really is that actually it is, when you have a cross-sectional study, it's quite difficult to differentiate between the two. You can do it, but it's not so easy. So longitudinal studies generally can provide more information. So I want to go back to COBRA and just show you one example to finish off here about this. And this is looking at the brain and the predicted brain age in COBRA. Now, what have we done? Well, I have to say I can't take any credit for this. This is from James Cole within the collaboration and the neurologists and people working within that team. But what James did was we benefit because everybody in COBRA has had an MRI scan, so we have a lot of detailed information about the brains and how they're changing. So James took that information and was able to then develop a model to actually predict how old the person's brain was relative to their chronological age. And what we're using is a measure called the brain predicted age difference, which is the brain PAD. And that's essentially taking the difference between how old we predict the brain is from the white and grey matter data in the brain scans and what the person's chronological age is. Now, just in case that's still a little bit unclear, if you look at the figure on the top left there, if you have your 45-degree line, if you're in the top half of that figure, then your predicted brain age is older than your chronological age, so your brain is older than we believe it should be. If you're in the bottom half, then it's the other way around. Your brain is younger than you would expect. But of course, we can look at that predicted age difference to actually look at how the brain ages have changed. So here's the characteristics. Again, it's probably one of the biggest studies of MRI scans in this group. We can look at the predicted brain aging, and we can see that on average there, the people with HIV have brains that are slightly older than we would expect. The people without HIV have brains that are slightly younger. So certainly there is an absolute difference in the brain aging there. But remember, I said we need to look at the slopes. So here is now I'm showing the age on the x-axis, the predicted brain age on the y-axis. And you can see, as we would expect in both groups, as you get older, your brain ages. I mean, that's what we would expect. But we couldn't see any evidence that those slopes differ. So when we introduced the interaction term, no evidence there that there was a difference. So certainly for us within COBRA, when we look at that, we're seeing a pattern that certainly would suggest accentuated aging, but maybe not accelerated aging. There are other factors, I've not got time to go into them, but we are investigating associations with exposure to different treatments, to other cardiovascular, lifestyle factors. And I should also point out that data I showed you there was baseline data, and these models take a long time to perform, so the longitudinal work is ongoing. But we have got longitudinal data on neuroimaging, so if you don't believe the mathematical models, you can just look at the imaging scores. And look at those. You can still see differences between both groups at baseline, but over a 2-year period, both groups deteriorate at the same rate. No evidence there, at least over 2 years, that there's a difference. And if you're more interested in your brain function, well, these are the neurocognitive testing results, or at least some of them. We're seeing the same patterns when we actually do the neurocognitive testing. So in this case, people actually improve over time. There is a difference at baseline. People improve, possibly because of learning effects, but they go at the same rate. So there is really no evidence there that there is an accelerated aging profile. So to bring that all together then, is it true that HIV causes premature aging? Well, I think possibly for some outcomes there may be some signs of premature aging, probably more likely to be an accentuated aging approach, and what that means potentially is there may be some hit of HIV or the treatment or something. But maybe for people who are then controlled on treatment who are doing very well, actually then there's no real evidence that they then decline at a more rapid rate than other people. Equally, we need to think about the lifestyle, the behavioural characteristics, because they're likely to confound associations there, and they make those differences that we see look a lot bigger than perhaps they really are. And I think that only time will tell. I mean, we still need to follow these longitudinal cohorts. I know there are cohorts being set up, certainly in the region as well here, to look at aging. When the results come through from those, I think we will be able to investigate that in more detail and be a bit more robust in our conclusions. But until then, I think we need to be cautious when we make these statements. So I just want to finish there. I wanted to thank the COBRA collaboration because this has been an amazing project to be part of, certainly working with Peter and his team. It's been a really good group. And I have to thank James and Davide and Nilcha for helping me with the slides. So thank you very much.